Hi everyone, it's Miss G. The purpose of this short video is to explain how the terms opinion, fact, hypothesis, law, and theory are all used in science. We'll start with the easy terms. The first is opinion. An opinion is just a personal belief that is not objective, tested, or testable as stated. So if you want to know if something's an opinion, ask yourself, is this a personal belief or a personal judgment or a personal view? And then ask yourself, is this a statement that is not testable? If those two statements are true, then this is an opinion. For example, if I say, of all the marbles in my set, the blue ones are the most beautiful, that's an opinion. If I say, my tap water tastes really horrible, that's an opinion. Okay, next term is fact. Facts differ from opinions. A fact is an objective and confirmed observation about the natural world. So to determine if something's a fact, just ask yourself, is this an observation of the natural world rather than an explanation? We're just looking for observations here. Facts are agreed upon statements that objectively describe something or state something that actually happened. We use these all the time. For example, if I say, a marble rolled off of my desk and dropped to the floor 1 meter below, that's fact. All right, the next term is hypothesis, and we've definitely come across this term already in this chapter. Hypotheses are extremely important tenets of the scientific process. So by definition, again, a hypothesis is a statement that's testable and that offers a possible or tentative explanation, and it's always based on some observations or some kind of background research. So when you're looking to determine if something is a hypothesis, ask yourself, is this something that's scientifically testable? For example, if I say, if a marble and a magnet of identical mass, size, and shape roll off of my desk, then the magnet will hit the ground faster because it's pulled by the Earth's magnetic field. That right there is a hypothesis statement. Is it scientifically testable? Sure. I can take a magnet and a marble and knock them off my desk and see if they hit the ground at the same time or not. When I do, it turns out that they are going to hit the ground at the same time. This is not a hypothesis that is going to be supported, but it's a hypothesis nonetheless. And notice that it also contains some kind of explanation there. Now I'm going to talk about scientific laws and theories. These terms can be tricky because they're often used in a different way out of the context of science. A scientific law is, by definition, an analytical statement that allows scientists to make a prediction about how the natural world will behave under a given set of circumstances. To determine if something's a law or a statement is a law, just ask yourself this. Can this statement be used to predict how a system will behave under different conditions, and or is there a mathematical equation associated with this? That's very common for a law. Just remember, scientific laws have to be simple, true, universal, and absolute. Here's a good example of a scientific law. Okay, this would be Newton's universal law of gravitation, which just describes the force between two objects relative to their distance apart and how heavy they are. But it's universal because it works for any two objects, whether it be an object in the earth, like you and the earth, or even the force between two students sitting in a classroom. It's important to understand that laws rarely change because they're observational statements. Remember that. An example of a law that has changed somewhat that you might have heard of is the equation F equals ma, or Newton's second law. And this is a law that actually doesn't hold true for objects at or near the speed of light. And this has only been determined in the last 50 years or so. But prior to that, we just didn't have a way to measure objects that were going that fast. Here's some more examples of scientific laws. Newton's 3 laws of motion, Kepler's 3 laws of planetary motion, Boyle's law of gases, we'll learn about that later on this year, and the law of conservation of mass and energy. Now, a theory is different than a law because it provides an explanation for why things happen. By definition, a theory is an explanation for a phenomenon in the natural world that's really well supported by facts, by tested hypotheses, and by scientific laws. So, if you're determining if a statement is a theory, ask yourself, is this a statement that's supported by scientific evidence, and does it offer an explanation or answer the question why? An example of a theory would be Einstein's theory of general relativity. Understand that a theory is the grandest synthesis of a large and important body of information about some related group of natural phenomenon. Here's some more examples of theories: the theory of evolution, the theory of plate tectonics, atomic theory, or quantum theory. Note, too, that theories can change as more evidence is produced. For example, we're going to learn in this class about atomic theory, or theories behind what we think the atom looks like. And over a 200-year span, the theory about what the atom looks like has changed incredibly as we've gained more observations and more insight about what the atom really looks like. So we've had to change our theories to match that new information or that new data. A couple of other points I wanted to make about theories. In experimental sciences, a theory can never be proved. It can only be disproved by an experiment. A theory is an explanation of a set of related observations, as I've said before, or events based on proven hypothesis and then verified multiple times by detached groups of researchers. So a single scientist alone could never create a theory. He or she can only create a hypothesis, because the theory has to be based on a pool of evidence, observations, and laws that have been gleaned by a large community of people. And just to repeat, there's a strong distinction between a law and a theory. Remember, a law governs a single action. It's an observable statement, whereas a theory explains an entire group of related phenomenon. This is an observation, and a theory answers the question why. I hope this was helpful to you. This is just a slide that shows you references for the pictures and some of the information that I used on this screencast. Thanks.